too. I like the back.
I give you my circle. Yes, they're exactly. As long as you like I give you my first favorite.
I know. But I just did not know that you.
I know. It's just like making me want to cry.
No.
I'm not working at home.
I'm really good one.
Yeah.
Why do you want to take my water?
Right, how much?
Biology.
You'd rather play this stuff?
Did you listen to it? Yeah. I swear. We haven't even number in our class. Trisha, do we have an even number in our class?
I don't know.
We got partners for
Why is
biology.
close?
They got to base their own.
It's very
They
close.
leak it too.
I know. I know. But I really.
Oh, I see. I was. I cut myself on the night yesterday.
Yeah.
I was cutting somebody's bread and just cut right in my finger. I was going really fast, so she's like, and I was like, yeah, just cut myself. And I looked at her and pulled my glove, and I couldn't feel it. And I looked and I was like,
We're not late if you don't shut the door. Wait, where do I sit?
so,
Yes, fine.
there.
I don't want to. I won't listen to you. I'm not gonna listen to you.
Way in the back. You're back behind, Rayleigh's here. So you can scoot up if you want to scoot closer, they're not even here, so you can do that. So. Okay, so Ryan's gone still. We're missing what? Sokol, Rayleigh, and.
Yeah, I know.
Ah, there they are. There they are. All right.
I rushed out of there for no reason.
Sure.
I'm not.
I could take them off.
Okay, we'll start here in a minute. All we're going to do today is just do a couple notes. We'll be done. If you need to finish up page 111, you can do that. I know some people are already getting it done, turning in. That's great. It's due today. Just make sure that if you have any late work, get that turned in. You know, stuff that in the grade book that you know was missing, you didn't have a score for it, something like that. Just make sure you get those turned in. Let's see. Got a bunch of 111s here, which is good. Page 61.
And I can't
Good. 111s are started.
Hey, Boris, you know if I handed mine in? You know if I handed mine in something I did yesterday?
111. Let's see, I got Rachel. Cassie's yesterday. Lucy's yesterday. Sam's and Trinity's. Yeah, I got yours.
Okay.
Alright. Alright. Start here in a second. Hopefully those vein kids get here.
Yeah. All the bank kids are here.
Yeah, so what's the deal there? So maybe they're all gone. Alright. Well, we'll just start with notes, and if they show up, they show up. Now, we did this PowerPoint yesterday. I'm going to flip through these slides basically as fast as I can click. We did section 2.5 yesterday, which was postulates and proofs. The big thing yesterday was talking about these postulates, and we hit our first theorem yesterday before we let out. And then we talked about what proofs are. We need to know these, especially for these next couple sections. You know, they're going to ask you, you know, to identify certain pictures and identify certain situations. So it's a little bit different than what we did in the first chapter, and I'll explain as we go. All right. So the goals today. I want to obviously go through some of these postulates. So postulates 2.7, 2.1 to 2.7. Talk about theorem 2.1, which yesterday we did the proof of that, correct? We showed how that works, like the intro. Okay. Now, the main goal, after we're done through these, because I'm going to click through these as fast as I can because we did these yesterday, right? And they were online yesterday. I want to do examples like what the homework will eventually look like. Not today, we don't get there. But like, what will it eventually look like? What are you going to do with this stuff? Because I mean, it just seems like it's just stating like definitions, which it kind of is. But I'll kind of show you. And how it's definitely different than chapter 1 stuff that we did previously. All right, so postulates, axioms. Remember, a postulate is something that it's a mathematical statement. We accept it as pure truth. We don't need to prove it. It's a basis of knowledge that we start with, right? So an axiom is the same definition. We talked about that yesterday. This is kind of the older term that they used to use in the textbooks, but we accept these as truth. So these are the things we fall back on when we need to prove theorems. We use these postulates or definitions. Okay, so what we talked about yesterday was 2.1. Talked about, you know, when there's 2 points, there's exactly one line connecting them. So any 2 points. That's going to be the big difference from chapter 1 to now, to chapter 2 stuff, is that the idea is that any 2 points you can draw a hypothetical line connecting them. So we'll get to that later. Now, the thing I don't know if I explained to you guys yesterday, how they number postulates. In other textbooks, they just number them like postulate number 1, postulate number 2. Your book, it numbers them by what chapter they were originally found in. So it's postulate 2.1. So chapter 2's first postulate. Eventually, when we get postulates in chapter 3, they'll call it 3 point something, whatever that is. So I don't know if I explained it yesterday. Just so you know kind of why they call it those numbers. We have not had a postulate before this. I've stated some, but they're actually going to get a number later because we used them in the first chapter. Okay, so 2 points, you can draw a line. If you have 3 points, you can draw a plane that connects them. Any 3. Okay. What we talked about yesterday is how do you name them? Like how do you name planes? How do you name lines? That type of thing. If you're still not comfortable with that, we need to make sure that you get those down so you know how to write them. 2, 3, and 2, 4 are the converses. Converse 3, you take the sentence, you flip around. So this is the converse of 2.1. Is that when you have a line, there's at least 2 points on it. A minimum of 2. So that's what the word at least means. It's minimum. So there's 3 points there. Postulate 2.4 is the converse of postulate number 2.2, which is a plane contains 3 non-linear points. 3 points not in a straight line. That's a big deal. So this one, and it says the word at least, so there can be more. Great. 2.5 is when they intersect. You know, so like when I put 2 points on a plane, then the line that contains the points is also on that plane. It's like that. So it's like a duh moment, right? The dots are on the marker board, and the line connecting the dots is also on the marker board. That type of thing. 2.6 is where we start talking about when they start intersecting, like they cross. When 2 lines cross, they form exactly 1 point. Like that. Makes like an X shape, but this is how you get a singularity. The example yesterday was I was talking about like when you had 2 laser pointers that cross. There will be a beam in the middle where they actually touch. The lasers touch. So it's kind of like if my finger was one of those beams and this is my other laser pointer. Eventually, when they cross, they make a point. Okay, that type of thing, right? Postulate 2.7, when 2 planes intersect, they'll intersect at a line, right? So 2 planes. And this is the picture I used yesterday. This is the picture yesterday that I used to explain why they had to be non-collinear points. Like, why do 3 points have to be not in a straight line to make a plane? It's because of this situation right here. That if you have multiple points in a straight line, like colinear, right, straight line, then there's multiple planes that go through them. Like, because you can just tilt the plane at a different level and it goes through that. So that's the idea. So when you put them in this non-collinear, then it makes one individual plane, not multiple planes like that thing. So that's postulate 2.7, right? Then we talk about the theorems. Remember, theorems are properties that we need to actually prove it to be true. We talked about the word conjecture yesterday, where it's a conclusion to the statement, but you use inductive reasoning, like patterns. So I think the example I used yesterday is like, if you noticed your neighbor washes their car every Wednesday, what do you think is going to happen this next Wednesday? Well, they're going to probably wash their car. It's a conjecture. It's you're noticing a pattern. You're making a conclusion off of it. It may be true. You have to prove it. You have to wait till Wednesday to see what happens. So that's the idea there. Again, proving these statements or conjectures, there's methods. So we can use paragraph proofs, or we can, those are called informals, where we just explain it out loud. We can use statement of reason, which is the one that I prefer. And then indirect is the one we'll eventually get when we start talking about parallel lines. So that's the one where you go kind of outside the box to prove something. And I'll explain that later. Those are definitely harder than one. All right, and those indirect proofs really require that you know your properties really well. So I'll explain that when we get there. All right, now theorem 2.1. This is like if m is the midpoint of this segment, then the two segments have to be congruent to each other. We talked about that yesterday, like how to prove that. This is the goal, is to show that the two sticks are congruent. That's what those symbols mean. The two sticks are equal in length. Okay, and we did, I think it was like a 3-step proof. It's one of the first proofs that they do in every textbook. But again, how they number the theorems, it's the chapter number and then the first theorem that we learn. Okay. Eventually, like in the later sections, I think it's section 2.7, we learn like 4 more theorems. So they're definitely going to be coming up more and more and more now. All right, questions, comments on any of this stuff? I know that was like a brief, like quick flick through what we talked about yesterday. The goal today is to talk about, and that's due, right? The goal today is to talk about how that applies to homework problems, like this. How can we use those postulates and theorems to explain something about this picture? Okay, so I have a couple sentences that I'm gonna I'll put up on the board here, and I want to see what you think about this picture, so you can like converse with your neighbors and stuff. So I just want to think out loud. It's kind of like it's a yes or no question, and then why. So like what postulate, what theorem was it? So this is where you're going to get some practice knowing your postulates. So if you need to have your computer out to like look at that PowerPoint that I gave yesterday, because I posted online yesterday, you can go through that and you can click. But if maybe you wrote them down, you can have them in front of you. But I'm going to give you a couple sentences right now about this picture, and I'm going to see if it's yes or no. Okay? So that's what we're going to do today. We're just going to practice these. I have about 3 or 4 pictures we'll try. We have a couple sentences that I want to see. It's basically a true or false question. And then why. So, first one. P and Q intersect at line R. Now the book does this really goofy thing. They write, instead of like at line R, they put in line R. I think it's goofy, it's weird grammar, but I guess it's correct. All right, so. All right, true or false? P and Q, the planes, intersect at line R. So, true? Okay. Now, why? No, that's but why?
I'm going to say false because Q is just the line, or you know what I'm talking about, like, it's not really a point.
Oh, you're talking about like this is
Yeah.
just the name of it?
Yeah.
Okay. But why? Why did they... You said yes, which I'll agree with. The plane P's P is this one going to the back, and then this one, and they do intersect at line R. Okay? But why?
When planes cross, they make one line.
And what postulate is that?
2.7.
Ah, that's a reason. You see that now. That's a reason. It's postulate 2.7. Postulate 2.7 says when two planes cross, they make a line. That is true. Make sense? See, now you guys got the idea now. Yeah, all right. So now you're on the same page with me. Okay, next sentence. Same thing. We're going to use that same picture. Lines R and what's my other sentence? Line and R and N intersect at point D. R and N. True, okay, for trues. So R and N, so if you don't know, this is R, that one, and this is N. Now, yeah, two lines intersect and then make a point. What number, which postulate was that? 2.6. Remember, 2.6 and 2.7 are the ones where it's intersecting stuff, right? 2.5 is the one where you put dots on the plane and it makes the line on the plane. And then the rest of the 4 is basically explaining what a plane is and what a line is. Okay? Except for Theorem 2.1, that's the midway idea. Okay, so these are good so far. All right, let's talk about the next one. Line N contains C, D, and F. True or false? Why? Good. So, C, D, and F, they're non-coplanar, right? They're not on the same plane. So the idea here is C and D, yeah, they're on line N. F wasn't. It's on a different plane completely. Now, the proof of this and why it's false, okay, is because if you look at postulate 2.5, it says when you put points on the same plane, then the line that connects them is also on the plane, right? The problem is these are on different planes. You can see it. These two, well, I guess this one's technically on F, but these two are on the front plane. These two are on a different plane, so there's no way you could draw one line that would hit all three of them. Now, if I would have said, instead of F, if I would have said E, is that true or false? That's true. Now, so C, D, and E. Now, that's a true statement, but what postulate is it? What postulate is it? 2.3 said that if you're given a line, there's at least 2 points on it. Well, that's a line, right? C to D. There's at least 2. So there could be more. There's at least 2. There is another one, and E it happened to be it. So that would be 2.3. Okay. Do we feel comfortable with this picture? Can you kind of see it now? The R, M, and N, those are the names of the lines. P and Q, right now, these are the names of the planes. What's another name for plane Q? Can somebody give me another name for plane Q? Plane ABC. I like it. So plane Q, this is the same name. ABC. Is there another name instead of ABC? BCE or DCE? Yeah. Now, you've got to make sure that when you name it, you've got to give me 3 that are not in a straight line. I like BCE, right? BCE is fine. So if you don't know, BCE. Those are fine. The reason why, they're non-collinear. I don't want these 3. The reason why, those 3 actually have multiple planes touching them. They have the bottom plate as well. So I don't want that one. So give me 3 non-straight lines. So you could have said ACE for all I care, or ACD, I don't care, but they had to be not in a straight line. Okay, let's see. pretty much about it. Yeah, that's all I got for that. All right. So let's move on to the next picture. So same exact concept. So now we're going to get a little bit more challenging now on the types of questions. So here's your new picture. If you can kind of see the plane here. This dashed line means it's like poking through the paper like this. That makes sense. They're trying to show that it's going through it. They're showing it's in the back. The one below. All right, but here's the next couple questions. Same exact idea, true or false, what theorem, why is it true, why is it false, that kind of thing. All right. M, K, and N are co-linear. M, K, and N are co-linear. Okay, so we have a false. Any disagreements with false? Any disagreements with false? Anybody?
Yeah.
Ah, I got it. Good. It's true.
Sure.
Why? Look at theorem. Look at, or postulate. I mean postulate 2.1. That's 2. Or sorry, not 2.1. 2.2. Sorry, 2.2. Postulate 2.2. What did it say?
So we got the one point.
If there's 3 non-collinear points, one plane touches them. This is the difference. Now, it was a trick question, I know. Because you look at it, you're like, oh no, there's no plane touching those. It's a trick question. It's different than what we did in chapter 1. Chapter 1, you had to list things that were on the picture, correct? You had to, oh, like, the ones that are coplanar right now are N, A, and K. They're on the same flat surface, on that yellow piece of bread or piece of cheese kind of thing, right? But now what you have to think about is that there does exist a plane that would hit M, K, and N. There is a plane that would touch all 3 of them, even though it's not drawn. It is there because now we have postulates that says there exist planes when there's 3 points that are non-collinear. Even though it's not drawn, there is a plane that would hit all 3 of them. Okay, does that make sense now? It's kind of a trick question. I want to see how you guys would agree with that. All right, so now you guys can see how this is very, very different than in chapter 1. Because now you got to think that there could be one that exists. Okay, let's see. NK. N and K. So they are collinear. N and K. They are collinear.
True.
True. Why?
If 2 points are on a plane, never mind.
Oh, not that one. I agree with true. Aha, was it 2-1? Postulate 2-1. 2 points, there's always a 1 line that can be drawn towards them. That was 2-1. They are collinear. Even though it's not drawn, they are technically in a straight line with each other. That's weird, right? Now, I'll agree, like later on we have the actual line. We could do 2-5, right? We could draw the line that's actually come on the plane itself. But they are collinear, which is another trick question. That is very different than what we did in chapter 1. Chapter 1, you could only list the ones that were drawn. Now it's a free-for-all, because now you know that they exist. Okay, any questions, comments with this picture? Okay, so far the 2 pictures have been pretty straightforward. They're pretty easy to look at. This one's a little goofy because it's 3-dimensional. Okay, but let's definitely take a look at a different picture altogether, something that's definitely difficult to look at. Okay, it's like a wedding cake kind of a thing. Okay, this one for some reason is just tough for people to look at. Okay? This is tough. Now, what you got to remember is that this is a 3-layer cake, so it's kind of like tiered. Okay, so here's my question. Now we're going to start getting into difficult pictures. K, G, and B. Agreed. They're not on the same plane. There's no way that there's going to be a line that would contain all three of them. The reason why, this is the difficult part about this picture, it's hard to see it. B, point B, is actually a little bit off that line. It looks like if you were to draw this line, you'd hit point B, right? That's what it kind of looks like. But you need to remember, this level here, this second tier, is actually in further. So it's kind of like, here, let's see if I can give you a rough idea here. All right. Here's my little box. This give me the bottom layer of your cake. Here's my little cup. All right. So here's my cup. So what happens here, the corner here and here, this is K and G. This is point B. You can most definitely see they're not in a straight line with each other. Like B is a little bit offset. It's almost a full inch like away from the line. The line's up here. This is where the line's going. You can see that B is not touching it. Okay, that's the hard part with these pictures, is that later on, they're going to give you difficult looking pictures, and you have to kind of name those same exact reasons. Okay? So this one is most definitely false, and I would fall back to to the postulate 2.5, right? When you have 2 points on a plane, then there's a line that contains them that's also on the plane. Well, this one, B was not on the same plane. That's why I kind of fabled it. Okay, now, what if I said they're coplanar? What if I said that now? Not collinear, but coplanar. That's true. That's true. Even though it doesn't look like it, they're not drawn. They're technically on the same plane. Maybe not on the actual cake itself, but there exists a plane that would actually touch all three of them, because it goes back to, what is that, postulate 2.2? It said through any 3 points there is one plane that would touch all of them. That type of thing. Okay, that's the part where it's very different than chapter 1. Chapter 1 we would have said they're not in the same plane. One's a little bit offset. But now we know that there exists a plane that could actually touch them. So that's the differences. Okay, does that help you out? Kind of see the picture? Okay. Definitely wanted to talk about that. All right. Next, let's see. Okay, last picture of the day. Now we get to difficult. Cake looked hard. Now this is most definitely different. Okay, so what's happening here is you have a flat plane here, and then you have something cutting through it. So like this is going through the picture, right? So it's like a blade cutting through the paper. Okay? So this is like the background, just the blades covering it then. I always find this weird to show a little dash line. This should have been yellow, but all right. But there's a series of questions about this one. Points. C and B are collinear. Sure. They only named two. It's automatic. I didn't even have to look at the picture. It's automatic. If B and C are repetitive, they're collinear, because that was that postulate 2.1, right? Through any 2 points, there's a line that exists, right? That can connect. Let's see. DA, the line here, lies in plane P. DA lies in plane P.
False.
You gotta imagine drawing DA, right? Because it's not drawn for you. Is it on that plane? Yes. Now the reason why is A on plane P. Yes, it's on the blue part. D is also on that plane. It's right where the knife actually touched. It's right where this blade actually hit plane P, the blue part. It's right there. So if both of them are on the plane, the line's on the plane. That's postulate 2.5, right? Even though it wasn't drawn, you had to draw it yourself. That one, I know it's difficult to look at. When I first looked at it, I was like, God, is that on there? Yeah, it's right at that spot. Okay? And I want another name for line EF. I want another name for that line. GE. Yeah, that works. GE. Is there another one? GF. FG. What? EG. You could be the smart aleck and switch F and E around. FE. It's the same thing. Okay? But don't do that silly thing where you name it with 3 letters. Don't tell me it's GFE. Don't tell me that. It's got to be 2 letters, because if you look at all the definitions, all the postulates, lines have 2 points on them. So you name it with 2. That's the idea. Where does line AC and GF intersect? So let me write that down. So line AC intersects GF where? What do you mean? That's how you name an intersection. It's the point where it hits. Now why? Why is that true? That's postulate 2.6. So if you look at postulate 2.6, it says when 2 lines cross, they make 1 point. Singularity. Does that make sense now? And then I could ask the same thing. Where does plane Q and P intersect? Line DC. The line, the actual line touching them. Okay, you guys feel comfortable with some of your postulates now? At least a little bit better, now that you kind of know what the numbers are. Okay, that's it for today. Very easy and done. So you have the last 10, 12 minutes here, where you can just kind of work on 111 if you're not done. If you still owe me something, like in the grade book, you're missing something, it's got to be by this afternoon, so I can get that graded. It's the end of the quarter today, technically. So my grades will be submitted basically tonight after I'm done grading everything that's like. Football game tonight, where are we at tonight? good weekend.
Tori Sloan, Nick Jones, come to the office, please. Tori Sloan and Nick Jones. Haley Frost, come to the office, please. Haley Frost.